Okay, let's do numbers 16 through 19, and then we'll finish number 20, the FRQ, in a separate video. So the integral of sine of 2x plus the cosine of 2x dx equals. So one of the first things we can do here, and there's a few different ways of doing this, but the way I kind of look at it here is I can split that up into the integral of the sine of 2x plus the integral of the cosine of 2x. In both of these cases, I'm going to let u be 2x because, again, we have a composition of 2x with the sine function and 2x with the cosine function. So du is going to be 2 dx. So in both of these, I need a 2 in front of the dx. So I can go ahead and put in a 2 in front of the dx as long as I balance it with a 1/2 out front. Plus, same thing over here, cosine of 2x times 2 dx, as long as I balance that with a 1/2. So we have then 1/2 times the integral of the sine of u du plus 1/2 times the integral of the cosine of u du. I'm going to go ahead and continue horizontally. So I get 1/2. Now, the integral of the sine is the negative cosine of u plus 1/2, and the integral of the cosine is the sine of u. So we end up getting, this is multiplication, so be careful here. This is negative 1/2 the cosine of u, which is 2x, plus 1/2 times the sine of u, which is 2x. And then don't forget our plus c. And we see that answer right here in B. All right, continuing with number 17. Usually when we have E, the U, the composition piece, the U piece is that square root of x. Usually, I would say a large majority of the time, the power of E is going to be our U. So U is going to be the square root of x, which is x to the 1/2. So du is going to be 1/2 x to the negative 1/2, which is 1/2 times the square root of x dx. All right, so things are a little different here in that I need a 2 in front of that root x dx. And again, what I'm going to do here is just write things a tad differently here. I'm going to actually write it as e to the square root of x times 1 over the square root of x dx. The reason being trying to match that up to the du I have over here. The problem is I need a 2 in front of this, which I can balance since it's division by 2. I can balance with multiplying by 2 on the outside there. So I get 2 times the integral of e to the u. And now this entire thing is my du. And the integral of e to the u is e to the u plus c. Replace the u value back in. So we get 2e to the x plus c, or 2 to the e to the root x plus c. So A is the answer. 18. As I said, usually we let u be the power of e, which in this case here we have 2 e's, and the power is just a plain old x. So things get a little tricky here. Sometimes you can use the answers. Notice 3 of these have ln. Remember the derivative of ln of x, let's say, is just 1 over x. So when we see something like this, we look at that denominator, hoping maybe we can work out some sort of integral there. So if I let u be the denominator, then du, the derivative of 1 is 0, plus the derivative of e to the x is e to the x du. So we can, and again, this takes experience, I understand. I can rewrite it like this, which means now I can write this as 1 over u times, and this whole thing is du. And the integral of 1 over u is the ln of u. Replace the u back in. Don't forget the plus c. And I get the ln of 1 plus e to the x plus c. If you are quick, sometimes with multiple choice questions, if you get a little stuck on this, you can go ahead and derive each of these. Because remember, if the integral is b, then the derivative of b would have to be this. So the integral, the derivative of ln of 1 plus e to the x would be 1 over 1 plus e to the x times the derivative of this, which is just e to the x. And there we go. We can see that that's the answer. So if it's multiple choice, you can always do that. 19. Um, 19, I would say, is very similar to the problem we just did a couple of seconds ago, number 15, where a little algebra is going to help us here. So we're going to split this up. And again, I can split the sum when it's on top, not on the bottom. So I'm going to split it into x cubed over x squared dx plus the integral of 5 over x squared dx. So this becomes the integral of just x dx plus the integral of 5x to the minus 2 dx. So the integral of x is x squared over 2 plus 5x to the minus 1 over minus 1 plus c. So I get an x squared over 2, which looks like c or d, plus, and then we see that this 5x to the minus 1 becomes minus 5 over x. All right, that finishes the multiple choice part. The next video will be the free response question.